Okay. Okay, if you can open your worksheet or you can see from my screen. So this is the lab that we are going to do, a basic hydraulic circuit. Okay. Um, if you go down, okay, the objective for this lab, there are two objectives. Say one is to draw, assemble, test, and describe the operation of a single double-acting hydraulic cylinder in extension, retraction, and stop position. Okay, that one circuit that you have to do. Another one, the second circuit, is to draw, assemble, test, and describe the same, but using a single two-directional hydraulic motor. So one cylinder, another one is motor. In two rotation direction. Okay, so that's your objective for today for this lab 3. So the apparatus, if we are in the lab, okay, we have the apparatus lah. We have the hydraulic strainer, we have the pressure relief valve, the pressure gauge, the DCV, and whatnot, the hose and everything. But since we are doing it online, we just doing it by software. So we are not assemble the real components. So this apparatus, you just write it in your report, but we are not. I mean, for your lab, we are not going to do it. So your apparatus. So the procedure, okay. So draw the relevant hydraulic circuit using the software. This Automation Studio. You can open your software. Okay. So I open my software. This is my software. Okay. Can you see my software? Okay, you have
Yes, sir.
You have two columns, one for the component and one for the place where you want to draw the circuit lah. So open this circuit, you can open from here lah, new project, and then you will open your this column, second column. Okay. Okay. We go back to this lab sheet. Okay. Test the circuit using the software. Assemble the circuit you have drawn in the software. And then test your assembled circuit to show that it is fully functional. Before testing, please consult your lab supervisor. Okay, maybe this procedure involve because in real life, in real lab, you need to assemble the circuit properly. I mean, using the component, and then before you run it, you have to consult me lah. But now, since we only assemble it in a software, so you don't need to consult. There's no safety risk or no anything. You can assemble in your software and then run it in the software. I mean simulation lah. Okay, and then write a report on what you have done. Okay, this the most important thing. Number 5 ni, the procedure number 5. You have to write the report. You have to describe what happened in your circuit from the start until the completed the circuit. Okay, so in this particular assignment, you must produce two circuit. Okay, one using the cylinder, another one is using the motor. Okay, they give you the instruction here. Okay, how you can do it? Okay, it's very easy. So this is the circuit that they want you to draw in the software. So there are hydraulic cylinders, there are DCV, okay, there are pressure relief valve, there are pump, there are filters, and there are tank or reservoir. Okay, so what you have to do is, when you're using your software, okay, it's very easy. Okay, you have your component in your left column. You just drag what you need in your circuit. So you drag your component inside this column to draw a circuit. Okay, now you have your tank or reservoir. Okay, and then you need what else? After the tank is the filter, where your filter. So you find your filter. Okay, and put it in the circuit. Okay, you can rotate it if you want to have a very similar diagram to the lab sheet. Okay, so you have your filter, and next you need your pump. Okay, so you put your pump in the circuit. Okay, and then you need What else you need? Someone? Pressure. Okay. So you need your pressure relief valve. Where is it? Pressure relief valve. Okay, this one. I think okay. This is pressure relief valve. Okay. So drag your pressure relief valve, and then you need DCV. So this is 4-3 DCV. 4-3 DCV. Not, in this lab sheet, there is an error here. A few very small error. In this diagram, it shows push button and spring return kan? Kan? Ada push button and spring return. So you need to change the spring return to push button as well. So both sides is push button lah. Okay. So when you in your software, so you find the 4-3 DCV, 3242 43 deliver. Okay, so this one. Okay, and then like I said, you need to change this operator ni, mechanical operator ni. How you can change it? Click the component, and then right click on the component, and you have your properties, and then you can change. There is one left actuation and right, and for right actuation. Okay, so you can choose. So this is lever, so we want push button with this one, and also for the right actuation we need the push button as well. So this is a push button, then click OK. So now you have a push button lah on both sides. Push button ni left or also right. Okay, the last one I think you need the cylinder lah. Okay, the hydraulic cylinder, which is this one, double acting cylinder. So you track your component in this circuit. Okay, now you have all your components. What you need to do is just connecting the dots lah. So in real life, you will use a hose to connect all the components. Okay, but in this you just use connecting the dots lah. Okay, from the reservoir, from the tank to the filter, reservoir or tank similar, and from the filter to the pump to the P. P ni referring to pump kan, where it's coming from, the fluid, and then it goes out to output to the cylinder, and the cylinder will come back to the B, and the fluid will go out from T to the tank. T to the tank. But in circuit you need to put another tank, okay, here, so that you know after they come out from this DCV, the fluid goes back to the tank. In real life, in real lab, it doesn't mean that you have two tanks. It's just to represent, to show you where it goes after that. Okay, it's only one tank. If you're in your lab, we are using only one tank. Goes out to the component, go to the cylinder, and the fluid will come back to the similar tank. But when you draw the circuit, you just put the diagram to show where it goes after that. Okay, so don't confuse that. Oh, there are two tanks. Tak. It's only one tank, one similar tank. But when you draw a circuit, you need to put this diagram to show where it goes after that. Okay. Okay, you have your, so the fluids go to the tank, and you need your pressure relief valve goes back to the go to the line so that you can pressurize the circuit. And you need another one here, so the fluid can go to the tank after from the pressure relief valve. Okay. Sorry. Okay. So now you have a complete circuit lah. Okay. All your circuit is connected and complete, and you can run. You can run your circuit. Okay. Just click this run button. Okay. And you can push button here and see what has happened. So the cylinder is expanded, okay, and then push back to the normal position, and then you push button again, the cylinder is retract. Okay, this is a normal position, and when you push the button, the cylinder is expand. You push back to normal position, and when you push the button again, the cylinder is retract. That's what happened, and you need to discuss what happens to the fluid when in the expanding position. Okay, where the fluid is flowing out, and when on the trap position, where the fluid is going out. Okay, where is the flowing of the fluid in the circuit. So you need to discuss that. You need to write a report for this circuit. Okay, so that's one. So this is the first circuit, and like I said, there are two circuits that you need to draw. One using the cylinder. So the second one, you just change the cylinder to the motor. So you have your motor here. So you just change. Or you need to end first. Okay, before you can change anything, you need to end the simulation first. Okay, so the second circuit, you just need to change this to the motor lah. Okay, it's just simple like that. You can delete it and put your motor, and then you can wait, let me rotate this one first. Okay, and then you just need to connect the dot again lah, A to A and B to B. Okay, so you have a complete circuit of a motor. Okay, so you can run as well and see what happens when you push button. Okay, the motor is spinning in this direction. Okay, counterclockwise. Okay, if in the real lab you can see lah, you can hear the motor is spinning, but in this circuit you cannot see. You can just watch the arrow which direction the motor is spinning or rotating, and then it's in normal position again. And when you push that button, the motor is rotating to the counterclockwise. That's what happened to the circuit, and then you need to discuss it lah. Alright, so as simple as that. Okay, so they give you all the direction instruction, how you can do it. Okay, one for the cylinder circuit, another one is for the motor circuit. Okay, this is your similar diagram, but you're just only using the motor circuit. Okay, alright, any question?
Setakat ni tak ada sir.
Setakat ni tak ada sir.
I think it's very simple. That's why it's called basic hydraulic circuit. It's very basic. So I leave it to you as a group. Okay, do it on your. I think every one of you need to open the software, need to open the lab sheet, and draw assemble, test your circuit in the software, and play around with this. Okay, you can change whatever you want. Maybe you want to try the different DCV, and there are a lot of DCV, 4.2, 3, 4.3, whatever. You can change. You can also change the mechanical operated to lever or whatever. But in the report, they want you to put the push button. But for the sake of learning, you can play around with the circuit. Okay, just to see what happens, or ada error ke kan. So you know how to familiarize yourself with the software on how to assemble a complete circuit. Alright, so I leave it to you as a group. Do it and discuss it, and lastly you need to submit a report, a group report. Only one report for your group, but like I said in the beginning, I suggest to all of you write a report as well. Okay, for your learning. What's happened to the fluid, and where it goes from the tank to the pump or whatever. Oh, I forgot to show you one thing. Sorry, let me show present again. Sorry, before we go. Okay, you see my software? Nampak?
Nampak sir.
Okay.
Nampak sir.
In the industrial practice, okay, normally if you take this pump unit, the simplified representation, okay, this is represent these four components: the reservoir, the filter, the pump, and the pressure relief valve. So I will show you what happens if I just put this thing, okay, and connect the dot. You still can run it, okay. See, it's still a complete circuit, and you still can run this hydraulic motor cylinder. because this triangle, the black triangle, is a representation of the four components, the one that we draw before. So just for your learning lah, there's a apa, you can put this in your circuit. But for your lab report, they want you, we want you to draw everything lah, the reservoir, the filter, and the pump, and the pressure relief valve, so that you know apa, what's the circuit, the component on in the circuit. But in real life, in the industrial, they just draw this lah, apa, triangle. So just want to make sure you know that, so that you don't confuse what is this. Okay, so that's all. Okay, I'll leave it to you. Again, you can, your group leader can make a meeting and do it together in a group, and we will come back online at 40 past 3, 3:40. 3:40 we can gather again and we can discuss, or if you have any question. Okay, that's all for introduction. Have fun playing the software, and we meet again.
Okay, sir.
Boleh sir.